Good morning, everyone. Today I will be presenting our project titled Hospital Patient Record System, developed by our team Dua Farooq and Iman Siddiqui. This project focuses on designing a simple yet efficient way to manage hospital patient information using programming concepts in C language. In today's healthcare environment, the management of patients' records is one of the most important yet time consuming tasks. Hospitals and clinics often deal with hundreds of patients every day, and keeping the records updated manually can be difficult. Our system provides a digital alternative to handle patient data quickly, accurately, and in an organized manner. This project highlights how programming can solve real life problems and contribute to digital healthcare. Our project addresses the challenges hospitals face when managing patient records manually. Paper based systems are often slow, prone to damage, and difficult to search through. By creating a digital patient record system in the C programming language, we provide a solution that simplifies record management. The system allows adding, viewing, searching, and updating patient information such as name, age, disease, and ID. It demonstrates how even basic programming knowledge can be applied to make healthcare processes more efficient and reliable. This project is a step by step towards the digital transformation of medical record keeping. The main objective of our project is to design a system that efficiently manages patient information digitally. To break it down, our goals include organized record keeping, ensuring that patients' details are properly stored for easy access, improved efficiency, reducing the time required to find or update records, minimized errors, preventing mistakes that commonly occur in paper based systems, user friendly design, making it simple enough for hospital staff to use without technical training, educational purpose, helping students understand how arrays, functions, and conditions in C can be used to solve real life world problems. Through these objectives, our system becomes both a practical hospital tool and a great learning project for beginners. Now, how it was solved. We implemented the solution by developing a simple and user friendly C program that performs the main functions needed in a hospital record system. The program supports the following operations: adding new patient records, viewing all patients' data, searching for patients by ID or disease, updating records if corrections are needed. To achieve this, we used arrays for storing data and functions to divide the tasks logically. The system uses a menu driven structure where users simply select an option to perform an operation. This makes it easy for even non technical users to manage patients' data efficiently. Now, we have architecture of the system. The architecture of the patient record system is modular and simple, making it easy to understand and extend. Let's discuss its main components. Number one, we have data storage. The data for each patient includes their ID, name, disease, and age. All this information is stored temporarily in arrays, allowing up to 50 patients to be managed at once. Number two, we have modules of the system. Add patient adds new patients and assigns them a unique ID automatically. Then view patient displays all patient records neatly. And then we have search by ID or disease, which allows quick lookup of a specific patient. And then update patient enables corrections or modifications in the data. Number three, we have program flow. The program uses a continuous menu loop that displays options repeatedly until the user decides to exit. This makes navigation intuitive and user friendly. Number four, we have technical terms and data handling. The system uses loops, conditional statements, and string comparison functions like strcmp to manage and search data effectively. Number fifth, we have scalability. Though currently designed for temporary storage, it can be easily upgraded by adding file handling for permanent data storage or by integrating it with the database. Overall, the architecture provides a balance of simplicity, functionality, and flexibility. The flowchart represents the logical flow of how our system operates from start to end. When the program starts, the user is presented with a menu of options such as add, view, search, update, or exit. Depending on the user's choice, the program calls the corresponding function. such as if the user selects add, it asks for patient details. If search is chosen, it looks for a record by ID or disease. The process continues until the user decides to exit. This flowchart helps visualize how user input drives the program logic and how different modules interact with each other. Then, we have results and assumptions. After developing the testing our program, we achieved successful results. The system was able to add and display multiple patient records accurately, search by both ID and disease with correct results, then update patient data without errors, and operate smoothly using the menu interface. We also validated the system with several input cases to ensure reliability. The only limitation is that it currently stores data temporarily, but that can be improved with file handling in future versions. Whereas in the assumptions, for the smooth working of the project, a few assumptions were made. We assumed that the system would handle a maximum of 50 patient records. All data is entered correctly by the user without invalid inputs. The program would run in a standard C environment on a computer system. These assumptions simplify the design and ensures the program performs efficiently during demonstration. Now we have patient management system flowchart explanation. First of all, start. The program begins with the start node. This is where the execution begins. Number 2, initialization. The system first initializes data by preloading 3 patient records. It also sets a variable total_patient is equal to 3 to keep track of how many patients are currently stored. Number 3, display menu. The menu appears, offering 5 key options for the user. Add a patient, view all patients, search patient by ID, search patient by disease, update patient details, and exit program. Number 4, we have input choice. The user is prompted to enter a choice from 1 to 6. The program will then follow a specific path based on the user's selection. Now we have decision and function flow. In choice 1, add patient, calls the function add_patient. The system adds a new patient record if the list is not full. After adding, it returns to the main menu. In choice 2, view all patients, calls the function view_patient, displays all existing patient records on the screen, then returns to the main menu. Choice 3, search patient by ID, calls search_patient_by_ID, prompts the user to enter a patient ID. If found, the patient's details are displayed, returns to the main menu. In choice 4, search patient by disease, calls search_patient_by_disease, prompts the user to enter a disease name, displays all patients suffering from that disease, then returns to the main menu. In choice 5, update patient, calls update_patient_input_ID. The user enters a patient ID and then updates the relevant details, returns to the main menu. Choice 6, exit, displays exiting program message. The program then terminates. 5. Return to main menu. After executing any choice except exit, controls returns to the main menu, allowing the user to perform more actions. In summary, the flowchart represents a menu-driven patient management system that starts with 3 patients, lets you add, view, search, and update patient records, and keep looping back to the main menu until you choose to exit. In conclusion, the hospital patient record system provides a digital solution for managing hospital data effectively. By converting manual record keeping into an automated process, this system reduces human error, improves accessibility, and enhances overall efficiency. Its modular design makes it easy to understand, modify, and expand, suitable for both small healthcare centers and as a programming learning project. This project proves that even a simple C program can have a meaningful impact in the healthcare domain by promoting accuracy, organization, and the digital transformation of medical records. Thank you for listening to our presentation. We hope this project demonstrates how technology can make healthcare management smoother and more reliable. Through this system, we have not only applied programming concepts but also contributed towards a more organized and efficient healthcare process. Thank you so much.